YouTube channel at Akim Ola Online Mathematics. I want you to keep showering me with a lot of subscription. I need your subscription. Please kindly subscribe to my YouTube channel. I just want to be hearing notification on my phone. Also keep sharing and liking my video, and you can as well comment on my video. I will appreciate if you can do all this for me. We have another question at hand. Evaluate this particular question. Whenever you see this integral sign, this particular question is always on integration. Integration. And normally integration always have a formula. If you have to integrate xn dx, it will always be x n plus 1 all over n plus 1 plus c. But what we know is that this formula has limitation, because we have different aspects of integration, like the one on the board. Of course, we are still going to apply this formula to solve it, but we cannot apply the formula directly. This aspect of integration is substitution. Integration by substitution. What are we substituting? If you look at this, we have two terms. This is the first term, and this is the second term. The two of them cannot be simplified, cannot be integrated at the same time. So what are we going to do? We need to use a different letter, a letter that is different from what is on the board, to represent this complex term. That means I'm going to have let m is equal to 3 plus x raised to power 3. And whether you like it or not, there is always differentiation in integration. So where do we go from here? We are going to differentiate the two of them. If I differentiate m, I am going to have the m. If I differentiate a constant, I'm going to have a 0. And if I differentiate this, I will have 3s2 dx. So from here, I can now make the x as the subject of formula. If I make the x as the subject of formula, I will have the x. If I make the x subject of formula, that means I will divide both sides by 3s squared. I will also divide this one by 3s squared. 3s squared will cancel. This now implies that my dx is now equal to dm all over 3s squared. So what will I do? I will now go back to the original question. If I go back to the original question, I will have integral s squared. Then here I have already used a letter to represent the whole of this bracket. Let m is equal to 3 plus s cubed. That means I'm going to have m here raised to power half. Then my dx now, look at what we have here. We said dx is equal to dm all over 3s squared. That means I'm going to have dm all over 3s squared. Looking at this dot means times. I can change it to times, and I can also use dots. If you notice very well, if I should put a denominator here, the s squared will cancel. That means after that, I'm now going to have integral m half dm all over 3. Then I can now move the 3 to the back of the integral sign. If I move it to the back of the integral sign, that means I'm going to have 1 all over 3. As you can see, the 3 is a denominator. Don't make mistake with that. It should be 1 all over 3. Then we have m 1 all over 2 dm. Then we can now integrate this by using the formula that is here. If I integrate this now, I will have 1 all over 3 into m 1 all over 2 plus 1 all over 1 all over 2 plus 1. Then I'm going to have an arbitrary constant c. So from there, I will have 1 all over 2 into m 3 all over 2. That is, if you simplify this, all over 3 all over 2. Then I'm going to have plus c. Where do we go from here? If you simplify this one further, then you are going to have 1 all over 2 times 2 all over 3, everything m 3 all over 2, then plus c. These two we cancel. Then our final, oh my god, this is 3, I have 3 here. This one too is also 3. I have 3 there. Here now will now be 3. So we are going to go. Where do we go from here? We are going to have 2 all over 9. Then if you integrate, we are going to substitute back the value of this m. If you substitute back the value of that m, you will have 3 plus s cube, everything to the power of 3 all over 2. Then we have plus c. That is the solution to this particular question. So as you can see, solving question under integration is always very, very simple when you use the normal formula to solve it. So we are going to stop here today, but don't forget to subscribe to my YouTube channel at Akeem Ola Online Mathematics. Share and like my video. You can as well comment on the comment section of the video. I will appreciate if you can do that. God bless you. God bless me. We take it off from here next time. Take care.